So still got student that haven't uploaded your quiz. Let's check again. Fatin, you haven't uploaded, Fatin? Yun? You haven't uploaded, Yun? Tipo.
Yes, doctor.
You haven't uploaded your quiz, right? Uploading already?
I submit already.
Submit already. You just submit, is it?
Yes, because internet is slow scale.
Okay, I get ready. Tadi siapa dah? Fatin. Okay, Fatin pun dah dapat. Okay. Okay, now we continue. Okay, before I start the next chapter, since a student asking me about how to use calculator, the old version of calculator to using calculator solve the determinants matrix. Ni kan? Determinant matrix using calculator lama. Wait. So using Casio FX570MS. Wait saya So if let's say we are using this one, since I don't know how to, because I don't have this type of display, called apa? Calculator punya apa? Ni. So if let's say if you are using, if you are using this one. Ni Casio FX 5MS. Okay, saya besarkan sikit, tebalkan sikit. Okay, so if you want, the first thing you have to insert this matrix A dulu. So you have to key in this matrix. So the matrix A is 3, 1, 0, 1, 3, -1, 0, -1, 3. This one is matrix A, right? So if you want to key in the matrix in the calculator, you have to firstly have to press mode. Okay, first press mode 1 time, 2 time, 3 time. So you have to press mode 3 time. So you will see after you press mode 3 time, they will have like these equations. Number 1, math, like this. It will appear like this, right, in your calculator. So that means you have to choose number 2. Okay, so you press, and next step is you press 2. And then you will see on your calculator, ke atas ni kan, it will display MAT. Here, this one, because this one matrix, right, number 6. So matrix A, so 3 times 3, this one, right? So it will come out MAT like this. Okay, so you will see that is when you look at your display, so they will have a MAT on the top. So that means this is already in the matrix mode. Okay, so now you have to key in the matrix A first before we find the determinants. So matrix A, so you press how to key in the matrix A. You have to press shift and then 4. Number 4. If you look at number 4, on the top of the number 4, they will have a very small one, right? MAT. Okay. When you press shift 4, so it will come out this display. Dim, edit, mat. Okay. 1, 2, 3. So now I want to choose matrix. Okay. So now I will take number 3. I will press number 3. Okay. So after you press number 3, it will appear like this. A, B, C, and then answer. So for those who are not using this calculator, you just listen lah. Okay, I just explain to those who are using calculator, this type of calculator, because it's a bit different calculator. You have to press differently. But I think when you look at the maybe the Gauss, I'm not sure, is it Gauss-Seidel or Thomas method? I got explained also using this type of calculator, but I don't remember which topic already. Okay, now I want to define this metric, the whole metric as metric A. Let's say I define this A. So either you can define as A or metric B or metric C, doesn't matter. So now I want to define this system of linear equation become a matrix A. So then I will choose number 1. Okay, so I will press 1. So it will appear like this, MATA. Okay. So like this. Okay. So you just press. Yeah. Oh, sorry. Silap. Bukan metric. I'm sorry. Now have to key in first. Because matrix A don't have any value. When I choose matrix A, that means there is no value inside. I have to put the dimension. Sorry. Go back. This one. Sorry. Shift 4. Okay. Go to dim first. Dimension. Have to put the value first. Value of the matrix. So have to choose this dim. Okay. Dim means dimensions. Okay. Press 1. So it will come out like this. You press 1. And then it will come out A, B, C. So whether you want to choose matrix A, matrix B, or matrix C. Okay, so now let's say I want to choose this one as a matrix A, right? So I will press 1. So I press 1. So, okay or not? Wait, who asking me? Can you follow? I know.
Can, Doctor.
Can Okay, you can follow. Okay. Now, when you press 1, it will appear like this. It will appear mat A M time N. Lepas tu M what? Right, this right. That means the row M is row and N is column. So because this matrix is 3 times 3, right? 3 row and 3 column. So that means your M is 3. So you press 3. So equal to, press 3 and then equal to, and then it will ask you, okay, same, this one, M times N, mat A, what is your N? Okay, so your N is same, also 3 equal to, 3 equal to, okay, so it will ask you to key in one by one. The matrix A, 1, 1. Okay, so matrix A, 1, 1. This one. A11 is this value. Okay, because this is a 1, 1, this is a 1, 2, this is a 1, 3. Right, and this is a 2, 1, 2, 2, 2, 3. Yeah, no. So you key in all the value. So matrix A11 is 3 equal to and then matrix A 1 2 is 1. You key in 1 and then you press equal to, and then matrix A 1 3 is 0 and then equal to, and then go to matrix 2 1, 1 equal to matrix 2 2 3 equal to matrix 2 3 is negative 1 equal to, and then matrix A 3 1 is 0 equal to matrix A 3 2 is negative 1 equal to matrix A 3 3 is 3 equal to. So you already key in all the matrix. So you key in already? Finish, let me know.
Finished already.
Okay, finish already. Then you press, okay, and then you press AC. AC, you jangan press on You ingat, you jangan pergi press on. So remember, just press AC. Okay, so AC, now we want to do the determinant, right? Determinant of matrix A. Okay, now I have to go to the, when I want to do this one, I have go to shift and then tekan 4, shift 4. Okay, so it will appear dim, edit, mat kan. Tiga ni kan. Dim, edit, mat. Okay, 1 2 3. Now if you look actually at the right side, it still got some value. So you press this button. This button yang ke kanan kan, at this one yang ni kan copy, ini nak atas kan, okay, bawah kan. So we press this one, okay, pergi ke kanan, boleh. So it will come out this so it will appear this one, din and transpose this one. So now choose 1 because we want to find the determinant. So you press 1, okay, and then it will come out like this, determinants, right? And then ni underscore ni kan, boleh ke? Okay or not? Can you follow? Now come DET. Lee, can you follow or not? Okay. Okay. Okay, boleh? And then now you press shift 4 again. Shift 4. Okay, now because we want to do determinant matrix A, right? Determinant matrix A. Ni kan determinant matrix A. So now yang ni dah keluar. So matrix A belum keluar lagi. So sekarang awak kena pilih number 3. This one keluar macam ni kan. Dim, edit, mat. Nampak sikit. 1, 2, 3. So now you choose 3. You press 3 and then it will come out A, B, C, answer. And 1, 2, 3, 4. So now we want to find determinants of matrix A. So you choose A. That means 1. So you press 1. So it will come out like this. It will appear like this. DET MATA. So you just press equal to. So you get the answer. So you get 21. Boleh? Just win. Okay. Get 21 or not? Okay, boleh. Okay, I'll need dah. Siapa tak dapat? Ada yang tak dapat tak? Okay? Boleh Yang guna ni Casio FX 570 MS. Okay or not? Can you get this one? 21, okay?
Okay, Doctor.
Okay. So now, okay, now we go to the chapter 4. Wait nanti saya record dulu. I have to record first. I forgot to record just now. This one. Okay. So today we will continue with chapter 4, interpolations, and today we will start with the Laplace interpolation. So before that, wait, oh sorry, terkeluar pula. Just explain to you the interpolation first. Okay, so this chapter 4, interpolation. Okay, so basically interpolation, we have two methods. Okay, one is polynomial interpolation, and another one is piecewise polynomial interpolation. Okay, kita bahas. And for this polynomial, basically they have two methods. One is Laplace interpolating polynomial, and then the second one is Newton divided difference method. Okay, and then for the piecewise polynomial interpolations, we have two methods as well. One is natural cubic spline, and another one is clamp cubic spline. Okay. So for your syllabus in this numerical method, actually the syllabus that cover is, okay, Laplace interpolation polynomial, Newton divided difference methods, and also natural cubic spline. Okay, so this one didn't cover in your syllabus lah. So basically we will learn these three methods. Okay, so today we start with this Laplace interpolating polynomials. But before that, I will explain to you the polynomial interpolation first. So why we use interpolation, okay? So if let's say, okay, interpolation, I think that before that you learn before, sebelum ni kan, mungkin maybe in your secondary school. For example, let's say in a one table, right? Sometimes in one tables and we have like x value or y value. Let's say you have 0, this one is 10, 2, 15, and sometimes this one 5, katalah, and this is example only lah. Okay, maybe this one 4, you learn 6, and then okay, 20, 28, let's say. Maybe you want to find when the value of x is 5, what is the value of y? This one here. Kan? So normally you do interpolation based on like this, right? X ini. So biasanya mungkin awak akan buat like 20 over 4 contoh equal to x over 5 or something like this, or maybe like 28 over 6 will be equal to this value lah, y equal to 5, something like this, right? So this is interpolation. But what is the interpolations in this numerical method is when we have a set of data and we want that the graph, we want that all, we want to find the data, let's say this one, but passing through all the data point. Let's say we have a graph like this. Let's say we have a graph like this. This is y, this is x. And let's say I have a point like this. Okay. And let's say I have a graph like this. Okay, so let's say I want to find the value at here. Okay, let's say this one x, you know the x. I want to find the value at here. What is the value of here? When let's say the x is equal to 3, let's say. So let's say this is a 1, this is a 1, this is 2, and this is a 5 maybe, and this is 8 maybe. So what is the value here? But we want to make sure that the graph is passing through all the point here. So that's why we use this polynomial interpolations, okay? When we have a polynomial, the functions, then we want that the interpolation that we do, all the data, when we want to find the polynomial that going through all the data points, okay? So normally we have two methods, okay? One is the direct method, we call it by direct method. So this is one of the direct method is Laplace lah, okay? So another one is Newton divided difference tu lah. Newton divided difference, okay. Wait okay. So boleh faham kenapa why we learn this interpolation, because we want to find the missing point. That means the missing point. Missing point. Contoh kat sini lah, ini point ni tak tahu. So at here, this what is the value, but at the same time, it have to be go through all the data point through the polynomial. Go through all data point. Okay, so tak kisahlah that data point is what, how many data point. So it can be, the data point can be like this. Can be only 2 data point, or maybe we call it a linear polynomial. Okay, sebab polynomial it can be linear or polynomial, that means the first order polynomial. Kalau first order polynomial, that means we only have 2 data point. 2 point. So kalau lah one is x, so that means let's say we have this point, 1 point, 2 point. So the graph is like this. So maybe let's say we want to find, let's say this is x, and this is the value that we want to find. Okay, so that means here we got a value here. This is x naught, this is y naught, and this is a x1, this is a y1. So when we have 2 points, that means the n is actually is how to say, is 1. How to say how many data point is equal to n plus 1? Kalau sini, contoh this one, this linear, we have 2 points. That means 2 data points. So 2 data points, that means n plus 1. That means n is 1. Boleh? If let's say this is a linear, let's say we have a second order polynomial. Second order polynomial, we call it as quadratic. Quadratic. This is a second order polynomial where we will have 3 data points. That's this one. This. Contoh. Kenapa ni? Y, X. So, are you still with me, class? Are you okay? Let's say we have a 3 data point like this lah. Okay. Graph like this. Okay, macam ni. So here is the, let's say he start from this one. This is x0, y0, x1, y1, x2, y2. So this is 3 data point. So kalau 3 data point, n is 2. Macam mana nak tengok It's very easy actually. You see we start from x0 and then x1, x2. Kalau tengok 2 here, the n is 2. Just now, this is x0, start with x0, x1. So n is 1. Or maybe if you want to make it more easy, when there is 2 data point, that means this is, dia punya n adalah data point minus 1. That means n is 1. This one 3 data point, that means n is 2. 10 data point minus 1, that is a n. Okay. If let's say this is second order, if let's say third order, cubic is third order polynomial. Kalau cubic, say we have 1 point here, 1 point here, maybe 1 point here, and 1 point here. And then the graph is, let's see what you need. Okay, so we have this one is 4 data point. So kalau 4 data point, that means n equal to 3. Because here, if you look at this is x0, y0, x1, y1, x2, y2, x3, y3. Okay or not? Okay. Now let's say 4 order polynomial. 4 order polynomial, call it quadratic. 4 order polynomial. That means we have 5 data point. So mungkin graph can be like this. Maybe like 1, 2, 3, 4, 5, and then the graph can be like this. So the n is 4. Boleh. So tak kisahlah, maybe you are going to find at this point what is the value. Okay. So for this one, okay. So kalau lah ikut Lagrange interpolations, when we have this one, we will, saya akan terangkan Lagrange interpolation. Lagrange dia punya meaning. Go back to this one. I write the Lagrange. Lagrange interpolation. If you look at the book, it says that I think page. Saya buka buku sekejap Let's I open the book first. Remember what it says. Lagrange interpolation is a process of approximating a function f(x) and estimate the missing function value over the interval a, b, a to b in the case where the set of data is only have 2 points. That means or 3 points or 3 depending on what polynomial. Okay, kejap in conclusion, blah 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 blah. Kejap. So Lagrange interpolation is basically a process of approximating a function f(x) and estimate the missing function value in the interval A to B. So, contoh kat sini lah. Kalau lah contoh sini mungkin like here, from here until here. And here we got 1, 2, 3, 4, 4 data point. Okay, so it can be start from x0, y0, and then x1, y1, x2, y2, and seterusnya xn, yn, depending on the polynomial, degree of the polynomial, whether that is this one, linear first order polynomial, or quadratic second order polynomial, or cubic third order polynomial, or quartic fourth order polynomial, ataupun lagi-lagi. Okay, so now the formula, that means this Lagrange interpolation, it will come out a new function. So the function of this Lagrange interpolation is will like this. Saya besarkan sikit. Fn, wait besarkan lagi. X function or polynomial lah. This one is approximate. This one summation of Li x, okay, from I equal to 0 until n, and time with the fxi. Okay, so where okay, this one is a function, or this one is the polynomial. Okay, so it's equal to this one, the whole thing, this is the weighting function. We call it weighting function. And this is the y, value of y. Value of data at value of I, tapi apabila at x punya location lah, x point. So this is ni lah value of y ni. So boleh nampak hijau? Can you see that? Is it okay or not? Okay. Okay. Where this function okay, we go back to this one this weighting function, these weighting functions, you probably will blur. What is this weighting functions? Okay, so weighting function here adalah, this is weighting function and weighting function L x is equal to byproduct of When j equal to 0, j is not equal to I and x minus xj and xi minus xj. So, kat sini, depending on sama ada yang is depending on that polynomial, whether this is first order, second order, third order, or fourth order. So, where we can expand, this one, when I expand, let's say we have two data point, 2 point, okay? Two data point, I have x0, y0, and I have x1, y1. So when I want to expand by product, dia punya weighting function, so this one, the weighting function of this one, 2 point is linear, linear polynomial become like this. This one, for example, x minus x1 divide by x0 minus x1. Macam ni, time with x minus x0, x1 minus x0. Boleh faham tak? Where kalau you look at here, x is the value that we want to find. X ni tak tahu. Where that mean, contoh I write here. Let's say here, we have 2 point this one. Now, x I know, okay? But then I don't know this value. So now I want to find this value, okay? So x here, at this x, that means I will put at here, at this x, okay? Minus, okay, minus xj. So where xi minus xj? So normally we will start from the, depending this, let's say this, we have two data points. So we will start from x0. So that means x0 minus yang selain daripada beside its own, that means x1. And then this one, yang ni dengan ini akan sama. These two will be the same. You look at here, ij, xj. Okay? And then the next, since just now, we start from the, this one, right? x0. Now, because we have two x, one is x0, another one is x1. Another one is x1. So the next, we have to multiply x minus x0, x1 minus x0 ni. Start dengan x1 pula. x1 minus selain daripada dia, beside itself. Okay? So that means beside itself, that means x0. Okay. So now let's say I do example for linear, for first order polynomial, second order polynomial, third order polynomial, and fourth order polynomial punya weighting functions that you may understand. Okay, if you look at this one, the first one, this one, this one, dia punya weighting function L, okay. So L, dia punya Lx will be sama dengan, because since this one, we will have L not x plus with L1 x. Macam ni lah senang, okay. Since now our n is 1, so you start with 0, and then until 1, okay. So LO, the first weighting functions will be x minus x1, x0 minus x1. Boleh faham tak? Because this one, saya punya base, my base is this one, x0. Alamak. This one. Kan, sebab not. And then, kalau lah, sorry bukan plus saya silap sebenarnya, dia punya polynomial sebab, I'm sorry. Wait, sorry. This one. Let's say this one, I do this one. Asingkan, bukan. Sebab now it's a weighting function, sorry. I put here, weighting function here. weighting function. This one, face this one, weighting function. This one is x minus x1, x0 minus x1. Okay, macam ni. Apabila when we have x1, x, that means x minus x0, x1 minus x0. Macam ni. Di mana, where this one? If this one is 1, so this one also x1. When that one is not, this one also x0. Okay. Ini untuk linear. Kalaulah untuk second order. Okay. So second order, I will have L0 x. Perlu ada. Lepas tu perlu ada L1 x. And then need L2 x. Weighting function, we have 3 weighting function. Okay. So this one start from there. X minus x1, x0 minus x1. Selain daripada x0, x1, I still have one more, is x2. Darab dengan time x minus x2, x0 minus x2. Boleh faham? Can you understand or not? So beside the node itself, x0, and then you have to minus the rest. So because now we have 3 data points. So when you do this one as a base x0, so you have to refer minus this one. Another one is this one. So same to L1x, the weighting function of this one. Oh, sorry. Where is Class, are you still with me? Am I talking alone? Semua masih sini? Okay or not? Kita semua dah blur. Now, let's say this one. Kalau ini berapa agaknya? X minus, kat bawah senang sini x1 minus x0. So here is the same. And then sini x1 minus x2. Okay. This one tak keluar. Alamak. So now this one is x minus x2. So nice. To be easier, you put at the bottom first. x0, x minus x0, and then x2 minus x1. Here x minus x1. Macam ni. Boleh. This is when this is a second order polynomial. If let's say this one, we have 4 data points. That means we have to have a Lx, L1, L2, L3. Untuk yang ni. This one, sorry. This one, for this one. So until L3. So start from this one. So that's mean x0 minus x1, x minus x1, time with, I have to move this one to the right. Move. Uh-oh. Apa-apa. Okay. So this one continue. x0 minus x1, 2, x minus x2, and then x0 minus x3, x minus x3. Macam ni. By product. And then this one will be x1 minus x0, x minus x0, x1 minus x2, x minus x2, time with x1 minus x3, x minus x3. Like this. And then Continue with this one. This one, x2 minus x naught, x minus x naught, x2 minus x1, x minus x1, x2 minus x3, x minus x3. And this one, x3 minus x naught, x minus x naught, x3 minus x1, x minus x1, x3 minus x2, x minus x2. Like this. Boleh? Boleh faham ke? So depending, if let's say we have more data point, that means we have to multiply more. Okay? Okay. So this is the weighting functions. So if you want to find the polynomial, the functions of that particular polynomial, we have to time with this one, fx lagi. So for example, this one, I go to the linear polynomial kat sini. I use this one, a blue color lah. Okay. So now, let's say this one, linear punya. This one. Terlalu banyak lah ni. Linear, okay. So linear, just now we have 2 points. And then where n equal to 1, okay. So tadi saya akan, just now we have this L0, L1. So fx ataupun polynomial P1x, because y is 1, because n is 1. Tak nampak besarkan sikit. Because the n is 1. And mungkin saya make it 3. Make it 3. This one, F lagi tebal sikit lagi. Fx or P1x. So P1, because of the n, is equal to L naught x Fx naught plus with L1x time with Fx1. Okay. So that means this one, just now, we refine this one. So that means this one maksudnya macam ni lah. Like this is like x0 minus x1 time with Fx0 is actually the value of this one. Sorry, y0. So this means this is a y0. And plus with, just now this one, x1 minus x0, x minus x0 time with the y1, like this. Inilah. Okay, so this is the polynomial. So depending on x, let's say just now, let's say here, I want to know what is the value of this one. Let's say x here, I put 5, right? This is a 5. So we just put in the value here, 5. Here is 5. Here is 5. So we'll get the value of y. Boleh faham tak? Here. This is 5 minus 5 minus macam ni. If let's say the value of x is 5. Kalau let's say, okay or not class? Are you still with me? Abu, Hafizuddin, okay or not? You understand or not? Pening ah?
Yes, yes.
Okay, faham?
Okay.
Let's say now, how about, let's say sekarang saya ambil this one pula. Dia punya polynomial. P2x macam mana? Dia akan jadi L x f x naught plus with L1x f x1 plus with L2x f x2. Macam ni. Dia lagi panjang lah. Okay, boleh. Ashraf, okay or not Ashraf? If okay, then we go to the example. So what we need to know is, first and foremost, we have to know how many data points. First of all, we want to know how many data points. In order, we want to know the n. N tu berapa? Because data point is equal to n plus 1. Okay. So that means because when we know the n, that means we will have to know how many weighting function that we have to do. Okay. First, weighting function tu. Lepas tu kena and multiply how many times. If let's say, if let's say we have 3 data points, that means we have to do this one. The weighting function will be like this. Have 2, because we have 3x, x0, x1, x2. Kalau let's say we have 4x, that means the weighting function, the byproduct of this one will be longer. Boleh. And then after that, after we get the weighting functions, then we can find the polynomial, or we call it the how to say, Laplace interpolating polynomial. This one. Ini yang panjang ni. Okay. This is the polynomial, interpolating polynomial. Ini. Kalau let's say this one is the third, apa? Third order punya. Okay. Boleh? Okay or not? So now we do the example. Kejap saya nak ambil copy this one example. So kadang-kadang this one, the whiteboard is not functioning. So just put in the okay. So example 4.1. Example 4.1 in page 76. Given following data which is generated by the function y equal to, boleh nampak y equal to 1 over x, and then there is a table here, table 4.1, with the value of x, 4, 1, 2, 3, 4, 5, 5 data point here, 1, 2, 3, 4, 5, and then the value of y. So approximate f at 4.5 by using linear, quadratic, cubic, quartic Laplace interpolation, and find the absolute error for each approximation. So first of all, the exact solution we already know based on this one. Kalau tengok kat sini, we already know the exact solution as it actually. Exact solution tu berapa dapat? Sini, let's see here dah. Kalau tengok here, okay, this is the oh, tebalnya. Sekejap. Exact solutions A, y equal to 1 over x. So kalau lah, now over x, sekarang kita nak cari f 4.5 kan. So gantikan masuk nilai this one 4.5. So what do we get? One over 4.5. So 0.2222. This is the exact solution. Okay, now we want to find using kita mula dengan we start with the apa? Linear. We start with the linear Laplace interpolation. Okay. Kalau linear, how many data points already I mentioned before linear?
2.
Okay, 2 data point. 2 data points. Kalau you see 4.1, 4.1 pula. 4.5 is here, right? 4.5 is between 4 and 5, right? Kat sini. So that's mean we will use these 2 data point, 4 and 5. So only these 2 data point will be using. Boleh faham tak? So that's mean I will use like this lah. 4, 0.25, and then 5, 0.2. This is the X, this is a Y. Okay, so where this is N equal to 1, kan? So in, let's say, linear equations, okay, first of all, remember that we have to find L weighting function, L naught. So yang ni akan jadi X naught minus X1, X minus X1. Right. And then L1 is equal to X1 minus X0, X minus X0. Macam ni. Right. So, saya, kalau awak tak nak tulis, if let's say you don't want to write like this, you directly write the polynomial function also can. That means P1X equal to X, F, X1. Saya terus ganti masuk. That means I directly substitute. So ini saya terus kira. Okay, now we want to find 4 point. This one, right? 4.5. Okay. So I'll put the value here. X ni adalah 4.5. Okay. 4.5 minus X1. So this is X0, this is X1. This boleh. So X1 is 5. Boleh faham 5. And then X0 is 4 minus 5 here. And the value of Y when X is X0, this is 0.25. Macam ni. Plus with X is 4.5. The value that we want to find, X though. And then minus, okay, X0 is, kalau sini X0 is 4. Divide by 5. This is X1 is 5. X1 is 5 minus 4. And then time the value of Y. This one, the value of Y when X is X1. Ni kan ni X1, ni X1. So here is 0.2. Sekejap. Sampai sini, here, at this, dapat macam ni? Can you understand or not this one? Boleh?
Boleh.
Okay. Can boleh Okay, then I'll continue. So you just calculate. So what do you get? Okay. So mungkin senang kalau lah, let's say, okay, there is sometime, okay, now is maybe it's easier because we only have over 2 data points, okay? If let's say you have many data points, sometimes you just can do key in the calculation, your calculation in calculator, because here you can change to, let's say, I make it, okay, X is, if let's say X, I will use X. And then let's say X0, I will use A. X1, I will use B. So kalau sini, daripada sini, okay, I will change to X minus B, A, B. Macam ni boleh. So nanti, yang ni pun saya akan ganti, samalah. I will use the similar formula. Contoh macam ni. Let's say, ini susah sikit sebab dia tak nampak pecahan ya. The old, this one. Wait So this one, I will put alpha X minus alpha B kurungan bahagi, divide by alpha A minus alpha B. Kalau tak nak buat macam ni pun tak apa. If you don't want, you just do the calculation because this one is very easy. Just 4.5 minus 5, you don't know already, negative 0.5 over negative 1, right? So better, I just tell you, if let's say, if you have to key in a lot, so maybe you can use this one. And then, so, calculate, so, kejap. Calculate, kenapa dia tak dapat Kenapa dia keluar terus jawapan? Wait Oh, because this is a in math mode. Aduh. Now is go back to the complex. Pening lah saya. This one. Wait Go to this formula. Alpha x minus alpha b divided by alpha a minus alpha b. So calculate. Now what is your x? Now our x is 4.5. 4.5. And then a, our b, x1 is 5. X0 is 4. So that means you get 0.5, right? 0.5. 0.5 times 0.25. And now here this one. Kalau tak nak ubah, kan calculate, terbalik kan. B sekarang tukar kepada A. Tapi saya malas, jadi saya pun terbalikkan. 4. And this one is 5. So get also 0.5. 0.5, 0.2. Then dapat berapa? Darab 0.5 times 0.25. 0.5 times 0.25. Okay. 0.125 plus with, terus buatlah saya. Plus with 1. 0.1. 0.225. 0.225. Okay, so this is the approximation. So just now it's already said that have to find the absolute error for each approximation. So this one we have to find the absolute error. So absolute error dia punya formula apa? Remember? Exact minus approximate, ataupun approximate minus exact, doesn't matter. So 0.2222 minus 0.225. So get 0.28. Betul tak? 0.2222 minus 0.225. 28. So this is the linear. And then we have to find for the quadratic. So quadratic, that means 3 data point. 3 data point. So that means we'll choose 3, 4, 5. Okay, this is X, this is Y. Let's say this is called X0, X1, X2. So this is 3, 4, 5. The value is 0.333, 0.25, 0.2. If you don't want to draw the table, it doesn't matter. As long as you know that X0 is what, X1 is what, X2 is what. For example, let's say this one. You just can write like this if you want. And then for 0.25, because you know that there is 3 data points. So it doesn't matter. Anything also can. So this is X0, this is X1, this is X2. So now I want to find the Lagrange quadratic polynomial. So P2x approximate L naught x f x naught plus with L1x f x1 plus with L2x f x2. Okay, so that means this one have to be 4.5 minus, okay, x naught, start with the x naught. Saya kena tulis, okay, sekejap, saya tulis dulu, nanti kan apa ni, I write it first, okay. So here is x minus, start with the x naught minus x1, this is x1, and then x naught minus x2, x minus x2, okay. And then plus with the second one, x1 minus x naught, x minus x naught, and then x1 minus x2, this is x minus x2, f x1 plus with x2 minus x naught, x minus x naught, ini x2 minus x1, x minus x1, f x2. Macam ni. So equal to P2 4.5 equal to this one 4.5 minus x1 is 4. This is 3 minus 4. 3 minus 5. 4.5 minus 5. So the value, this one, the value of y when x is x naught, that's this one. 0.3333 plus with, okay, tadi we start from the x naught. Now, alamak. Now is x1, that means 4. 4 minus 4.5 minus, start dengan 3, mana 4 minus 3. This is 4 minus 5. This is 4.5 minus 5. And the value of y is 0.25. Boleh ke? Okay, are you okay? 0.25 is here. That means I bring this one to here. Yang ni tadi, just now. This one, the value of this one is this one. Okay, and then this one, the value of this one. Okay. Now, plus, tambah lagi, 5 minus 3. Oh. 4.5 minus 3. And then this one, 5 minus 4. 4.5 minus 4. So this is a value of this one. Fx2, that means this one, 0.2 here. 0.2. So kira dapat berapa? So you find. So this one also, if you want to put in a calculator, contoh this one, like for example this one, jadikan x and then x0 a, x1 b, x2 c. Tak kisahlah kalau tak nak pun. You don't want also, okay, doesn't matter. So L is just calculate itself because this one, yang ni congak pun boleh tengok. 4.5 minus 4, that means 0.5 over negative 1. Kan? So what you get here? This one. Again. 4.5 ni. 0.5. This one is negative 1. Kan? Time with any 5 negative 0.5, negative 2 time with, tak ada lah. Okay. Lepas tu time with 0.3333. Then you get negative, alamak, here. Oh. Negative 0.0417 plus with this one, 4.5 minus 3, 1.5 divided by 1 time with, ini berapa? Negative 0.5, 1 time with 0.25. So, correct or not? Negative. Betul tak? Salah saya. Something, wait ah. (1.5), this one is 1, negative 0.5. Oh, here is, wait, here is negative 1. Times 0.25. So get 0.1875. And then plus with, are you still with me, class? I'm alone here. 1.5, boleh ke? But 5.3 minus 3. And then divide by 5 minus 3. That's 2. And then time with 4.5 minus 4. That means 0.5. And then divide 5 minus 1. 4 equal to 1. 3/8, this value. And then time with 0.2. Time with 0.2. So 0.075 plus 0.075. And then plus with 0.1875 minus 0.0417. 0.417. So get 0.2208. So now we have to find the absolute error, 0.2222 minus 0.2208. So minus 0.2222. 0.0014. So this is a absolute error. Darren, are you still here, Darren? So now is 3 data point. And then we have to continue with the cubic, quartic lagi. So that means, kalau lah, let's say, cubic that means 4 data point. So this 4 data points start from 2, 3, 4, 5. So now we go to the cubic. Cubics, that means 4 data point. N is 3. So P3x equal to L log x f x like this, plus with L1 x f x1 plus with L2 x f x2 plus with L3 x f x3. Shafiq, are you still here, Shafiq? Boleh ke? So Shafiq, can you tell me the L Not X tu macam mana? Muhammad Syafiq.
I'm not sure, Doctor.
Huh? Not sure. Weighting function, awak ingat start from not. Kalau sini kosong, not. Kat bawah, we remember, okay, now, kalau 3, now we have 4 data points. That means we have X naught, Y naught, X1, Y1, X2, Y2, and then X3, Y3. You know, kalau refer to those value just now, start from 2, 3, 4, 5 ni kan. Maksudnya, we have 2, the value is 0.5, and then 3, the value is 0.333. Saya tak buat dalam table lah. Okay. And then, saya buat dalam table. Sekejap, saya buat table. Opening nanti. So, wait. I do a table. Okay. Now, we have ni, I. X0, X1, X2, X3, X, Y. X is 2, 3, 4, 5. Y 0.5, 0.3333, 0.25, 0.2. Okay, we have this 4 data point. So n equal to 3. So that's why we need to have weighting function start from L. Awak nampak kita ada kosong, 1, 2, 3. Okay, we have until 3. So that's why this weighting function have to be L0, L1, L2, L3. So based on how many n that we have, this one, n is equal to 3. Okay, so start from this, the first L0. So we have to refer to X0. Yang ni, X0 ni. X0 kita. So X0, kita akan letak X0 minus selain X0. Beside the X0, what X do we have? We have X1, X2. This is X3. So we have to minus X1 first. So this is X minus X1. This will be the same. These two value will be same. Okay. This setiap kali yang sini akanlah X. Nilai apa yang kita nak cari nanti. The value that we want to find. Based on these questions, the value that we need to find is 4.5. This one. So the X will be 4.5 for these questions. Kita kena cari nilai kat sini. Apabila when X is 4.5, the value of Y is what? We don't know. So now we have to do the interpolations in order to find the value of Y when X is 4.5. Yeah, I mean or not? Sini. Now we want to know at this point, 4.5 here, what is this value? This value, apa ni? Okay, so now go to the weighting function just now. Remember, okay, now we have X0, X1, X2, X3. So start dengan X0 minus X1. X0 selain daripada X1 ada apa lagi? We still have X2. X2. Now X minus X2. And then selain daripada X1, X2 apa lagi ya? We have X3. So X0 have to be minus X3. So this is X minus X3. Boleh ya Syafiq? Sekarang lebih faham. What is the function, weighting function though?
Yes.
Okay, after that we will time with the value of fx0. That means the value of y. This is the fx0. Time with this 0.5. Ini adalah the whole thing here is L0 X. And then kita kena tambah. We still have to plus with this one pula. Kan? L1. So start dengan L1. Remember X1. Sebab dia 1. Remember 1. So start with X1. So selain daripada diri sendiri, beside its own, the X1 is on, we have X0, X1, X2, X3. So here we start from X1 minus X0. X minus X0 time with x1 minus x2, x minus x2, time with x1 minus x3, x minus x3. Boleh? And the whole thing, this one, later on, we have to time with the value of the fx1. Apabila kita ganti this one. So this is the 0.3333. So this is L1x. And then L2x pula. Oh. L2x, that means, you see L2x, x2. Selain daripada x2, we have x0, x1, x3 kan. Okay, so we start dengan x2 minus x0, x minus x0. x2 minus x1, x minus x1. x2 minus x3, x minus x3. Darab dengan its own 0.25 punya value. Okay, plus with now x3 pula. x3 minus x0, x minus x0. x3 minus x1, x minus x1. And then x3 minus x2, x minus x2. Time with the value of y kat sini. Value of y ni. So time with 0.2. Sekarang gantikan masuk. Now you just key in the value of x. Semua x kat sini adalah 4.5. Because now we want to find the value of this one. P3 4.5. So kat sini semua x tu adalah 4.5, 4.5, 4.5. Here is the value 4.5. Okay, so x0, x1, x2, x3. So based on here, x0, x1, x2, x3, the value. Just put in, slot in. Boleh tak, Syafiq? Okay ke?
Yes, okay.
Oh. Now ganti masuk sahaja. So then awak boleh calculate. Contoh here, 4.5 minus x0 adalah 2. Bahagi dengan x1 adalah, tengok balik x1 is 3. 3 minus 2, macam ni. And then 4.5 minus x2. x2 is 4. Nampak? x2 is 4 here. So, and then x0 lagi. Saya silap. x0 is not 3. Sorry. x0 is 2. Tepat here, this one. Sorry. This one is x0. This one should be, sorry. Saya silap. Saya sepatutnya start dari atas. Sorry. Ya. Start from here. Start from this one. Here, this one, 4.1. 4.5 minus x1 is 3. This is 2 minus 3. This is 2 minus 4. This is 4. And then 2 minus 5. This is 4.5 minus 5. Macam ni. Time with 0.5. Okay. Plus with 4.5 minus x0 adalah 2. 3 minus 2. And then this one is 3 minus 4. 4.5 minus 4. 3 minus 5. 4.5 minus 5. 0.3333. Plus with 4.5 minus 3. Bukan. Betul. 4.5 minus 3. This is 4 minus, sorry, saya start dengan x0. x0 is 2. 4 minus 3, 4.5 minus 3, and then 4 minus 5, 4.5 minus 5, 0.25. Then tambah lagi 4.5 minus 2, 5 minus 2, 4.5 minus 3, 5 minus 3, 4.5 minus 2, 3, 4, 5 minus 4. And then time this, plus 1, 0.2. So awak kira boleh dapat berapa? So for this one, saya salin 0.0313 minus 0.1042 plus 0.2344 plus with 0.0625. And then the answer is 0.2240. So after get this one, find the error. That means 0.2222 minus 0.224. 0 dapat 0.0018. So boleh. Satu lagi nanti awak boleh buat. Boleh. Try buat. Try to do another one is the this one, quartic. When you have 5 data point. When you have start from 1, 2, 3, 4, 5. And then the value of y1, 0.5, 0.33, 33, 0.25, 0.2. So you need to have the weighting function start from L0, L1, L2, L3, L4. Panjang sikit. Semakin panjang lah. Kalau data point lagi banyak, lagi panjang. Dia punya weighting function kat sini kan. Weighting function lah. Weighting function dia lagi lah banyak. Lagi panjang. So sekarang kan, you will have like byproduct of 3 things. So later on you will have a 4. Lepas tu daripada L0, L1, L2, L3, ada lagi L3, L4 untuk quartic. Boleh? So I think I stop here first. If let's say we need another further example, then maybe we continue next class. Okay or not? Semua pun dah pening ni. Pan, are you okay?
I need time to digest first, I think.
Kejap. Before we stop, any of you have question on this one? Which part that you not understand? Huh? Siti Atika, okay ke tak? Siti Atika. Dah ke mana lah
Okay
semua?
je doktor.
Ha? Okay or not?
Okay je.
Okay je. Hishamuddin, ada masuk tak Hishamuddin? Ada? Masih kat sini? Hishamuddin, are you still here? Hishamuddin? Hishamuddin Hussein?
Yeah.
Masih sini ya? I stop sharing. Okay, boleh. So memang Haziq is not here, right? Haziq memang tak ada kan hari ni?
Ada doktor, ada.
Haziq? Muhammad
Ada.
Haziq Muhaimin. Ada? Awak ada kat sini?
Ya ada saya.
Bilanya awak masuk? Kenapa saya tanya-tanya tak ada? Selepas ada quiz lah awak baru masuk.
Tak, saya masuk tepat pukul 4.
Ha?
Tepat pukul 4 saya masuk.
Ya ke?
Ha.
Tak dapat scan?
Saya tak dapat rasanya.
Tadi saya tak ada tanya, tak ada jawab. Okay. So we continue next class. Okay, boleh. Rasa semua dah pening ya. If you need further more example later on next class lah, we explain more on this one. On this Laplace. Yang ni dah pening ke? Newton divided reference tu lagi pening sikit daripada ni. Ini this one actually is very straightforward. only you have to write more. Banyak kena tulis. Apabila when they have more data points, 3 data point, 4 data point, lagi panjang. But actually it's very straightforward. Okay, nanti awak balik, I will send to you the recording video, then maybe you can look back lah. Okay, so I think that's all for today. Thank you so much for your attention. See you again on Wednesday. Okay, so bye-bye. That's all. Apa nak tanya ada?
Thank you, Doctor.
You're welcome.